Hello, today we're going to be using the square root method to solve quadratic equations. Here we have x squared is equal to 16. I know that it's quadratic because my highest exponent is 2. Our goal is to find out what x is, so we think about how we would solve if this were a linear equation. We would think about operations that undo each other. So what will undo squaring? Well, that would be square root. So let's take the square root of both sides. The square root of x squared would just be x because x times x is x squared. You can also think about the exponent over root property. 2 divided by 2 is 1. And then what number do we square to get 16? That would be 4. And when you solve an equation, you want to know all the numbers that you can square to get 16. We can also square negative 4. Negative 4 times negative 4 is positive 16. And we just said that 4 squared is 16. That means we have two answers. We could have negative 4 or positive 4. We can write that together with a combined positive or negative symbol. So let's write that in front of the 4 to show that it could be 4 or negative 4. And when you're actually doing the process of taking the square root of both sides, park that plus or minus in front. Now let's take a look at a two-step equation. 9v squared minus 8 is equal to 1. Just like with the linear equation, we would undo addition or subtraction first. We will do the same thing with our quadratic equations. So I'm going to undo that minus 8 by adding 8 to both sides. So that will be 9v squared is equal to 9. Then we want to undo the multiplication by 9, so we'll divide. And then that will be v squared is equal to 1. We want to undo the square, so we'll take the square root of both sides. Square root of v squared will be v, and the square root of 1 is 1. Now let's take a look at a two-step written in a little bit different order. Let's say we have negative 4 minus 9n squared is equal to negative 85. So I notice it's a little backwards here, but we still want to undo addition or subtraction first. We're trying to isolate our variable expression. So we're going to undo that by adding 4 to both sides. So that will be negative 9n squared equals negative 81. Remember to bring down the sign. Now we'll divide both sides by negative 9. So that will be n squared is equal to positive 9. We'll take the square root of both sides. Square root of n squared is n. Square root of 9 is 3. So positive or negative 3. There are some odd situations that can happen, like this next one. It looks normal to begin with, but then we add 1 to both sides, and we get negative 25. Here we'll divide by 5, and then we'll take the square root of both sides. The square root of n squared is n, and then the square root of negative 5. Now that looks a little strange to us because of the negative. We know that 5 would just be an irrational, it'd be a decimal, but this negative, we haven't had that under a radical before in Algebra 1. And actually, we don't have to deal with that until Algebra 2. That gets us to those imaginary numbers like I equals the square root of negative 1. But in Algebra 1, we don't have to deal with that. If we see that negative under the radical, we're just going to write no solution. You might also see no real root. Either one is correct. Say we have 2n squared plus 7 is equal to 71. So we'll undo our addition, we'll subtract 7, and that will be 2n squared is equal to 64. We'll divide both sides by 2. That'll be n squared is equal to 32. We'll take the square root of both sides. And here we have a choice. We can either make a factor tree, or we can think of the largest perfect square that goes into 32. If we think about our perfect squares, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. 32 would be in between. So we'll start there and go up. 25 won't divide into it, but 16 will. 32 divided by 16 is 2. So we can rewrite that. Now we can use the product property, and that will be the square root of 16 times the square root of 2. I like using that property because some students forget which number is going to pop out and be outside the radical. This way it kind of keeps you straight. The square root of 16 is 4. 2 is not in our list, so that means if we took the square root of it, we would get a decimal. So this would be our exact answer. F of x is equal to x plus 4 squared minus 49. Okay, so this is still quadratic. So that means if we graphed it, it would look something like this. We know it's going to go up because that number is positive. Now we can graph using x-intercepts and a vertex. Here we can find our x-intercepts by thinking about, for every point that's on the x-axis, the y-coordinate is 0. So we can plug in 0 for y in an equation. Well, f of x is just fancy for y. It's just saying, hey, that's going to be a function. It passes the vertical line test. My variable is x. But it's just the y-coordinate. So let's plug in 0 for that. And I'm also going to use the symmetric property and flip this over to the left-hand side and put my f of x, or 0, on the right-hand side. And then now we have a quadratic equation we can solve. We're going to undo the addition or subtraction, just like before. It just looks a little different over here on the left. But that's okay. All of that's being squared, so we can undo that by taking the square root. Since our root and our exponent are the same, that x plus 4 is just going to fall out. And then the square root of 49 is 7. Now we still don't have x by itself. So what this means is that x plus 4 could be 7, or x plus 4 could be negative 7. So we have two little equations to solve. So here we'll take away 4 to get the 3 on this side. So that'll be x is equal to 3. One answer. Over here we'll take away 4, and that will be x is equal to negative 11. So now I know that x value is 3, and over here I'd have my negative 11, 0. Okay, so this is solving quadratic equations using the square root method. I hope you find it helpful. If you did, please share, like, or subscribe, and have a great day.